Hello, and welcome to the GPK Training Center. In the next few minutes, we're going to be taking a look at installation procedures for GPK fittings that, if followed, will reduce fitting failures. We're going to show you some in-the-field footage that demonstrates the right and wrong ways to install sewer fittings. We'll also utilize 3D animation to show you what occurs when proper installation procedures are not met. So, let's get started. The four main areas we'll be looking at today are bedding of pipe and fittings, vertical risers, axial joint deflection, and backfilling practices. The fittings that are subjected to the most stress on a job site are the T, the TY, the Y, and the elbow. For our demonstration purposes, we're going to be utilizing only the Y and the 45-degree elbow. Although the methods discussed today are valid for all types of fittings. Now, let's take a look at a visualization of a typical installation site. Please note that riser sections connecting two GPK fittings will be various lengths from the main line. The stresses on fittings can be equal at any depth, regardless of how deep the trench is. Almost all fitting failures can be traced back to this critical step in the installation process: inadequate riser installation. So, let's take a look at the bedding of pipe and fittings at a job site. Here are GPK fittings where the Y branch comes off at 45 degrees. It is at this point where proper installation must be done in order to avoid future system failures. The first step is to always provide a solid foundation under the mainline pipe and fitting. The main point of this support is to keep the pipe and fitting from settling, thereby changing the angle of the attached riser pipe, putting added pressure on the fittings. It's important to note that pipe and fitting must connect in true alignment in order to maintain the integrity of the system and reduce stresses. As you can see in this animation, if the mainline fitting settles, the angle of the riser pipe, which is embedded in the soil, causes pressure on the fitting, creating a break and system failure. The best bedding for pipe and fittings is always undisturbed soil. But in the event that is not possible, properly compacted fill of various types can be effective, as prescribed by the design engineer or the specifying agency. Local conditions may call for cement pads and even encasement of the entire connection, pipe and fitting, in concrete. After the mainline fitting and pipe has been secured, the next critical area is the grade of the trench wall, upon which the riser pipe will be laid. If the sidewall is not cut to grade to allow the riser to be laid against undisturbed soil, the transition from vertical to horizontal causes more downward stress than the fittings are designed to withstand. In these situations, additional engineered designs are necessary to reduce the chances of system failure. Now let's take a look at what is described as a true vertical riser, which is the source of the most problems and failures. A vertical riser may be defined as any rise that exceeds 45 degrees from the horizontal. This type of installation puts more stress on mainline fittings than any other type of installation. Remember, vertical riser installations should not be used unless some special design structure accompanies the installation. Before we show you some tested designs for stabilizing a vertical rise installation, it's important to understand what occurs if these special measures are not taken. Here's a vertical rise installation with a rise angle of 85 degrees. As you can see, even under no earth load, the weight of the pipe is stressing the fitting. Now, let's backfill the installation without proper compaction and see what happens. When the trench has been backfilled without the proper compaction, or additional stability designs built in, and the horizontal pipe coming off the vertical riser is laid on disturbed soil, the earth settles and drags the riser pipe downward with it. At the mainline joint, this results in overbelling, joint distortion, and even driving of the riser pipe deep inside the fitting itself, thereby breaking the fitting and causing a system failure. Now let's explore a way to help stabilize a vertical riser that has proven to be effective. This method involves a sleeve of PVC pipe placed over the riser pipe itself. Now this sleeve is usually sealed at the top and the bottom around the riser pipe to keep earth from getting between the sleeve and the riser. When this entire device is backfilled, any settling in the trench will cause the sleeve to move downward with the soil, but leave the riser pipe in place. Heavier walled solvent weld branches on main body fittings have also been effective in stopping drag down, which overbells fittings, causing them to break. Also, backfill material, which compacts easier, such as sand and P-rock, etc., and does not adhere to the pipe and fittings, can ease drag down forces on riser pipes. Perhaps the best way to avoid drag down joint breakage is to use deep socket fittings, which are designed to accommodate pipe movement. As you can see in this animation, with deep socket connections on both ends of the vertical pipe, drag down simply moves the pipe deeper into the fitting. The next area where problems occur in sanitary sewer installations is axial joint deflection. This often occurs when a Y is used at a service branch with a 45-degree elbow attached. Let's take a look at the problem this causes in detail. First, we attach the 45-degree elbow to the mainline Y fitting, which is at its proper 45-degree angle from horizontal. We then attach the service line and rotate it to make the desired 2% grade. As you can see, this deflects the service line, which puts it out of alignment to the connection at the other end. Problems then occur if the service line is pulled over to meet the connection. This places stress on both the joints at either end of the service line. The solution to this situation is to add another 45-degree elbow at the main line fitting. As you can see, this additional 45-degree elbow allows you to move the service line to its correct 2% grade without the deflection, which misaligns the service line to the other connecting point. It should also be noted that the same problem in vertical installations can be rectified in the same manner. GPK cannot stress enough the importance of proper backfilling and compaction. A general rule would be that starting at the bottom, the levels of fill should be more closely spaced or layered, then compacted to allow for proper support. Then gradually increase the amount of fill added per layer of compaction until the trench is filled. GPK recommends that backfilling be done in 6-inch increments and hand-tamped. Although this sounds a bit costly, redigging and repairing a failed line costs much more. Sewer fittings are generally the highest stress points in any sewer system and are often expected to take the most abuse. This video was made to show some common problems during installations. Some or all of the techniques discussed here may prove helpful in avoiding system failures. Installers need to use common sense, previously proven techniques, and engineering expertise to keep failures to a minimum. For a complete guide on sewer system installations, see the Unibel Handbook of PVC Pipe and the ASTM Installation Standard D2321. These books contain more detailed information on all types of installations than can be covered in this video. From all of us at GPK Products, Thanks for watching. To contact GPK Products Incorporated, write to 1601 43rd Street Northwest, Fargo, North Dakota, 58102, or call 1-800-437-4670. This video is designed exclusively for GPK products. This video is designed to illustrate proper installation procedures and shall not be construed in any way to extend GPK's expressed or implied warranties.